If you've been watching the optical communication space lately, you might have noticed a subtle but important shift. The conversation is no longer just about bandwidth upgrades. It's starting to move toward changes at the architecture level. And one term that keeps coming up is OCS, or optical circuit. It's switching. The reason it suddenly feels everywhere is not because the technology is new, but because it aligns perfectly with the current explosion in AI computing demand. For years, data center networks have been built around the logic of optical to electrical to optical conversion, meaning signal LS constantly switch between light and electricity during transmission. This worked fine in the traditional internet era, but as AI training clusters grow larger and more complex, the latency and power consumption caused by these conversions are becoming real bottlenecks, so the industry is starting to ask a different question. Is it possible to bypass this step and move CL loser to a fully optical network architecture? And that's exactly where OCS comes in. Its core idea is quite straightforward. Keep data in the optical domain for as long as possible and perform switching directly in light rat array. Then converting back to electrical signals. The immediate benefits are lower latency and reduced energy consumption, both of which are critical for our large-scale AI systems. Because at this stage, the limiting factor is no longer just the chip itself, but the overall efficiency of the system. In that sense, OCS is less of a simple upgrade and more of a structural adjustment. On the network side, now the question becomes why this is accelerating at this particular moment, and there are a few practical reasons behind it. First, the demand side has clearly changed. AI workloads now require far higher bandwidth and much lower latency than before, making traditional architectures increasingly strained. Second, the technology itself has matured, especially with NEMs, systems becoming more stable and cost-effective compared to earlier stages, making large-scale deployment more realistic. And third, the broader ecosystem is already in place. High-speed optical modules have evolved from 400 to 800 and are moving toward 1.6, effectively preparing the infrastructure for higher density connectivity. When you put these factors together, OCS shifts from a niche concept to a central variable worth paying attention to from an industry perspective. This kind of shift often signals the beginning of a new cycle, because it doesn't just affect one segment. It has ripple effects across the entire value chain, including optical switching equipment, components, modules, and even upstream materials. But it's also important to stay realistic. Even though the logic behind OCS is strong, the pace of adoption may not be very fast because it involves changes to the entire data center architecture, and transformations at this level tend to be gradual rather than immediate. A more likely path is that it will first be deployed in scenarios where latency and energy efficiency are especially critical, and then gradually expand, which means in the short term the impact will show up more in expectations and early orders rather than full-scale deployment. When looking at companies, the beneficiaries are unlikely to be concentrated in a single name. Instead, they are spread across different parts of the ecosystem, including firms that specialize in optical switching components, manufacturers of high-speed optical modules, and companies with strong system integration capabilities, but at the same time the barriers to entry are not low, especially when it comes to reliability and scalability, so not every participant will benefit equally. If you take a longer-term view, the significance of OCS goes beyond being just an other technology trend. It represents a deeper shift in optical communicating, on from simply increasing transmission speed to rethinking how networks are structured, moving from solving how fast data moves to improving overall system efficiency. And if this transition continues, its impact will be structural and long-lasting rather than short-term. So instead of looking at OCS as a quick opportunity, it may be more useful to see it as an early sign of where the industry is heading as AI computing continues to scale. The key question becomes how long current network architectures can keep up, and once clear bottlenecks appear, solutions like OCS may shift from being optional to becoming necessary, and that may be the real story behind all recent attention.